I am Anuradha Mathur and I have been teaching physics at Modern School Vasant Vihar. Now, we are going to see how we can use Kirchoff's rules for electrical circuits to find a condition for resistances for a balanced Wheatstone bridge. Let us see what our Wheatstone bridge looks like. It must have 4 resistances and the pair placed in series and they placed in parallel. If I mark this P, Q, R, S, according to Wheatstone bridge, a balanced bridge would happen if I have something to check the current flowing through this section like a galvanometer, then there should be no current in the galvanometer. We are going to use Kirchoff's rules to establish a condition for P, Q, R, S for a balanced bridge. What does Kirchoff's law state? The rule states, so first one is a junction rule, which says that if a current is entering a particular junction, then it divides into different sections in such a way that this value is equal to the sum of the others. So, how many junctions are there? A, B, C and D, and let us see if this happens. If I is the current entering A and say I1 goes through P, then from your rule the current in this section will be I minus I1. At junction B, this current I1 would divide to flow through the galvanometer, say this value is Ig, and through Q it would be I1 minus Ig. Likewise, we can establish what will be the current through S. At this junction D, Ig and this section has I minus I1. So, the current in this portion of the circuit would be I minus I1 plus Ig, and at C all this adds up to become I value. What is the second rule? The second rule is a loop rule, which says that if you have a loop like A, B, D, A or another loop B, C, D, then the potential drop across it is going to all add up to a 0 value. Let us start from here. I have marked this loop by taking it clockwise. So, I1 P, through this section the current is Ig. So, Ig into the resistance of the galvanometer, let us say it is G value. Now, the current is flowing opposite to the direction of current here. The current is like this and the loop is considering it in the opposite direction. So, I put a minus sign and I say I minus I1 multiplied by R, and this should add up to 0 from our second rule, which is our loop rule. In the second circuits, this little section here, we can start with what is happening to the current through Q. So, Q into I1 minus Ig, the current is this in this direction and the loop is considering it opposite. So, we put a minus sign there, I minus I1 plus Ig into S, and in this section also is the same way, it is going the opposite way. So, what would it be? It would be minus Ig into G, and this should become 0 as well. For balance condition, these 2 points should be at the same potential. That means, the current Ig should become 0. Value for the galvanometer resistance cannot become 0. However, Ig will be 0. So, our 2 equations will then reduce to I1 P minus I minus I1 into R equal to 0, and in this one it will be I1 Q, this term becomes 0, and here it will be minus I minus I1 S, and this entire term becomes 0 because Ig is 0. So, this is equal to 0. Finding the ratio of these 2 equations, you will get the value P upon Q is equal to R upon S. This indeed is the requisite for a balanced Wheatstone bridge. That means, the ratio of these 2 resistances must be equal to the ratio of the other 2. This is taken care of in a meter bridge, and we do not have to know all the 3 resistances to find any one of them. Instead of R and S, you have a 1 meter long wire, and a jockey can tap it at different positions. Therefore, the length of the wire involved will contribute towards R, and 100 minus that length will contribute towards S, and therefore, a same condition is established in meter bridge, and that can be used to find the resistance of any conductor for which we do not know the value, but you will definitely need another conductor for which the resistance is known. That means, knowing Q, you can find P, R and S would be contributed by the lengths of the wire for meter bridge using the jockey D. So, you have learned how a meter bridge is a useful variation of Wheatstone bridge. You have learned how the condition for balanced bridge requires the ratio to be there for the resistances, and this can be very useful in doing calculations, solving circuit problems, and you will remember that the junction rule and the loop rule from Kirchoff's law was used for finding this.